This conference will now be recorded.
This is the webinar on real-life applications of Laplace Transform. The key to success is to focus on goals, not obstacles. So, good evening everyone. I hope all are doing well. I'm Supraja from IT Department of Loyola Institute of Technology. I welcome you all for this wonderful webinar on real-life applications of Laplace Transform. A day without prayer is a day without blessing, and a life without prayer is a life without power. Now, I call upon Joel John to lead us with a word of prayer. Over to you, Joel John.
Today's Bible reading is taken from the book of Isaiah, chapter 11, verse 2. And the Spirit of the Lord shall rest upon him, the Spirit of wisdom and understanding, the Spirit of counsel and might, the Spirit of knowledge and the fear of the Lord. This is the word of God. Thanks be to God. Lord's Prayer. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. For thine is the kingdom, the power, and the glory, for ever and ever. Amen.
Thank you, Joel John. Now, I call upon Dr. R. Ravikumar, Associate Professor, the Department of Mathematics, Science and Humanities, to deliver the welcome address. Over to you, sir.
Thank you, Subraja. Honorable Administrator, respected Principal, distinguished resource person, faculties and participants. Good evening to all. I hope everyone is safe and doing good. Today, the Department of Mathematics has organized its fourth webinar of this year on the topic Real-Life Applications of Laplace Transform. I am very much privileged to welcome you all for this webinar. On behalf of our management, administrator, Principal Dr. Sujata Anand ma'am, and faculties, I extend my cheerful welcome to our resource person, Dr. V. Nagarani, Assistant Professor, Department of Mathematics, SRM Vallemai Engineering College. Welcome, ma'am. Thank you, ma'am, for accepting our invitation even in your busy schedule. Your presence makes us, thank you, madam. Your presence makes us very happy. I am very sure we will be able to enrich our knowledge by your presentation. Our warm welcome to all coordinators, head of the department, faculties of science and humanities. Welcome, sirs. I welcome all the student participants and organizing committee members of this event. Welcome, friends. Once again, I welcome you all for this wonderful technical event. Thank you.
Thank you, sir. Now, I call upon Ms. Jayashree, the Department of CSE of Loyola Institute of Technology College, to introduce our speaker for the day. Over to you, Jayashree.
Good evening to all. I'm very much delighted to give a brief introduction about our resource person, Dr. V. Nagarani, Assistant Professor, Department of Mathematics, SRM Valliammai Engineering College. Her excellent academic record is awesome. She did her UG and PG in Madurai Kamaraj University. Also, she had completed 3 courses through NPTEL. Her area of specialization is cryptography. She is serving to the students for more than 13 years. She was a resource person for AICTE sponsored faculty training program. Also, she has attended many conferences, seminars, and symposiums, and faculty development programs. She is a life member in various professional societies like ISTE, ISC, etc. To her credit, she has published papers in reputed journals. Currently, she is working as an assistant professor in the Department of Mathematics, SRM Valliammai Engineering College. We are fortunate to have such a distinguished personality as our resource person. She is with us to make the session more interesting and knowledgeable. Thank you, ma'am. for accepting our invitation and giving your precious time for us. We are eagerly waiting for your wonderful presentation, ma'am. Thank you. Over to you, Supraja.
Thank you, Jayashree. If you want to succeed, focus on changing yourself, not others. Now, most awaited session of the day. Let us go to enhance our knowledge in real-life applications of Laplace transform. Now, I request Mrs. V. Nagarani, Assistant Professor, the Department of Mathematics, SRM Valiamma Engineering College, Chennai. Over to you, ma'am.
Thank you, ma'am. Good evening to one and all present here. First of all, thank you for the brief introduction about myself. I would like to thank the management, Loyola Institute of Technology, Chennai, and my heartfelt thanks to respected principal of Loyola Institute of Technology, Dr. Sujata Anand, and administrator Dr. T. Arul Selvi for giving me this opportunity. My sincere thanks to the organizing committee, Dr. R. Ravikumar, Ms. T. Roslyn Velangani, Ms. Shyamala, Ms. Niveta, professors of Department of Mathematics, Loyola Institute of Technology, who are instrumental in bringing out this webinar. My special thanks to Roslyn ma'am for inviting me to deliver a lecture for the first year students in the topic real life applications of Laplace transform. And finally, my sincere thanks to Principal of SRM VEC and HOD Dr. S. Chitra, Department of Mathematics, for permitting me to deliver a lecture in this webinar. Okay, now I start the today's topic. So today's topic is real life applications of Laplace transforms. So now I am going to discuss about our contents. What are the topics we are going to discuss is first we introduce about what is mean by Laplace transform. What is the definition of Laplace transform, and basic results under Laplace transforms, and properties problems based on properties, and then how can we apply Laplace transform by using periodic function, and then initial and final value theorem. These are all under a Laplace transform, and other next part is inverse Laplace transform. Here also we are going to discuss some results and simple problems, and various techniques followed for finding inverse Laplace transforms, that is by using partial fraction method and convolution method. And finally, solution of the ordinary differential equations will be find out by using Laplace transform. So this is the major application of Laplace transform, that is for solving the ordinary differential equation by using Laplace. And finally, we are discuss some applications of Laplace transforms in real lives as well as various engineering disciplines. So now Laplace will be introduced by the mathematician, the French Newton Pierre Simon Laplace. He developed mathematics in astronomy, physics, and statistics also. So he work in calculus which led to the Laplace transform. So then later he focused onto the celestial mechanics. One of the first scientists to suggest the existence of black holes is Laplace transform. Laplace. So now main introduction about Laplace transform. Transformation is nothing but in mathematics, it deals with the conversion of one function to another function. That may not be in the same domain. So it will be converted from one domain to another domain, right? So Laplace transform is a powerful transformation tool which literally transforms the original differential equation into an elementary algebraic expression. Then it will be later simply transformed once again and come back to the solution of the original problem. So therefore, this transformation is named after the mathematician and renowned astronomer Laplace, who lived in France. And the applications of Laplace transforms are in the various engineering fields like network analysis, control systems, circuit theory, and many other areas. So this is the pictorial representation of the Laplace transformation, which means it will be transformed from one domain to another domain. That is, from time domain to frequency domain. So time domain means in here the problem is under differential equation form. It will be converted into algebraic equations by Laplace transform. And the reverse process is nothing but inverse Laplace transform. Next one, the definition of Laplace transform. Let f of t, the function f of t will be defined for all t greater than or equal to 0, that is non-negative integer, non-negative value. Then Laplace transform is denoted by L of f of t and is defined as integral 0 to infinity e power minus st f of t dt, or it may be denoted also as capital F of s. Here s may be a real, the parameter s may be real or complex number. And then main important thing is sufficient condition for the existence of Laplace transform is there are two conditions. One is the function f of t is of a piecewise continuous in the interval 0, infinity, and another one is f of t is of exponential order. Then only the Laplace transform will be exist for the given function. So this is the main existence conditions for Laplace transforms. And this table represents some important functions as well as their Laplace transforms result. So in the left hand side, we see that the function f of t equal to 1, when we applying in the Laplace transform definition, we replace f of t by 1, then the result will be 1 by s. So for the function f of t equal to 1, the Laplace transform is 1 by s. And for the function f of t equal to e power at, the transformation is 1 by s minus a. If the function in the function exponential part in which the power should be positive, then the transformation result will be negative, that is 1 by s minus a. And suppose if the function f of t is equal to e power minus at, then the result becomes f of s is equal to 1 by s plus a. That a is positive in the function, then in the transformation it will be negative. That's all. And from the third one, f of t is equal to t power and the function is t power n. So then the result of the function after the Laplace transform used, we get f of s is equal to n factorial by s power n plus 1. And similarly, so for sin at, the result is a divided by s square plus a square. For cos at, s divided by s square plus a square. And for sin h at, that is hyperbolic function, it will be as a divided by s square minus a square. For cos h at, it will be s by s square minus a square. And some more results are shown in this table. So the first up to cos h at, that results are very, very important because in many problems, the results are depending on the first 10 results. And now this slide shows that the derivation of the results. First one, L of 1. L of 1 means L of f of t. So here the function f of t is equal to 1. So in the Laplace transform formula, we have to replace the function f of t by 1. So that integral 0 to infinity e power minus st into 1 dt. Now we are going to integrating this function with respect to t and then applying the limit from 0 to infinity, right? So what is the integral value for e power minus st? That is nothing but e power minus st divided by minus s, the coefficient of t. Then applying the limit for t only. So now we can bring minus 1 by s outside and then applying the limit in the term of e power minus st, right? So here only we are having the variable t. So when we applying the upper limit infinity for this t, what will happen? E power minus infinity, right? What is the value of e power minus infinity? Okay, the value of e power minus infinity is 0. So that here the when we apply the upper limit, it becomes 0. Then minus of the lower limit is 0. So here when we replace t by 0, it becomes e power 0. E power 0 is nothing but 1. So that after simplifying, we get minus of minus plus 1 by s into 1, 1 by s. So therefore, the Laplace transform of the function f of t, that is 1, is nothing but 1 by s. And the second result is L of e power at. So for what? For any result, we have to use the formula for Laplace transform and just replace the function f of t by the given function. So here f of t is nothing but e power at. So in the definition, integral 0 to infinity e power minus st into e power at, because in this place f of t is in the definition. So e power at into dt. Now we have to integrating this function. For before going to take integration, we have to rewrite this function as e power minus st into e power at. We know that when we can take a product of two functions in which the base are same, then we can add the powers, so that it becomes e to the power minus st plus at. That is minus of s minus a into t. I can take minus c as common, so that it will be written as e to the power minus of s minus a into t dt. Now we are going to integrating this with respect to t, so it becomes e power minus of s minus a into t divided by the coefficient of t is minus of s minus a, and then applying the limit 0 to infinity. Why should we can take minus as common in this power? Because if it does not take the minus as common, then it becomes e power infinity. When we applying the limit, it becomes e power infinity. There is no result. E power infinity is equal to infinity. So that to avoiding that infinity, or for finding the finite result, we can take minus as common, right? So e to the power minus of s minus a into t divided by minus of s minus a. Here we can applying the limit for t. First upper limit is infinity. So e to the power minus of infinity is 0. So upper limit becomes 0. Then minus of lower limit. So minus 1 by s minus a into 0 minus lower limit is 0. So we can replace t by 0 here. So e power 0 is 1. So that the result of the Laplace transform of the function e power at is nothing but 1 by s minus a. So similarly, third result is Laplace transform of e power minus at, that is 1 by s plus a. And fourth one is the same process will be going to do in all the various functions. So for the fourth one, the function f of t is t. So the same definition we can apply, but here we see that the variable is t, and the integral function also having two functions, both are in terms of t. So we can applying either integration by parts formula or by Bernoulli's integration formula. So in this here I am going to use integration by parts formula. Integration by parts is nothing but integral of u dv, that is uv minus integral v du. So let us consider t as u and e power minus st as v. So then we can integrating this because u dv, right? So t into d of, we can integrating the term e power minus st, it becomes e power minus st by minus s, right? So now this is of the form integral u dv. Now after taking the integration, applying the integration by parts technique, u into v. So t into e power minus st by minus s, 0 to infinity, minus integral v into du. So v is e power minus st by minus s into d into u is t. So then now we have to apply the limit for the first term, that is the upper limit is infinity. Here e power minus infinity becomes 0. So upper limit will be 0. And then minus of lower limit, when we put t equal to 0, in this place, if we put t equal to 0, the total time becomes 0. So therefore, this first term becomes 0. So now here only we are going to integrate that and then applying the limits. So minus into minus, here we see that here one minus, here one minus, minus into minus plus 1 by s, right as it is. And the remaining function is integral of e power minus st. Integrating with respect to t, we get e power minus st by minus s, because t is the variable, so the coefficient is minus s. And then applying the limit 0 to infinity, the same reason we get the result as 1 by s square, right? So for the function f of t equal to t, when we applying Laplace transform, the result is 1 by s square. In general, fifth point is, in general, L of t power n, L of t power n, the result becomes n factorial by s power n plus 1. So this is also very important result. Similarly, we can find all the results. So I can skip this slide. Okay, now based on the results, we are discuss some of the problems, some of the examples. Let us see the first problem. Find L of 3 into e power 5t plus 5 into cos t, right? So here we are having two terms, L of 3 into e power 5t, and another one is 5 into cos t. We can applying Laplace transform in each and every term by the property of linearity. I will explain later, right? So by using the property of linearity, we can separate this function into two parts. That is, first one is 3 into L of e power 5t, because 3 is constant. When we take Laplace transform or any transform, when we take any transform for a constant, there will be no change. So that, so 3, write 3 as it is. So 3 into L of e power 5t. L represents Laplace transform. L of e power 5t, and here plus 5 into L of cos t, right? So now, first term, write 3 as it is. L of e power 5t, what is the main result? What is the result used here? Means L of e power at. What is the result for L of e power at? 1 divided by s minus a. So here what is a? Here a is nothing but 5. So the result is 1 divided by s minus 5. Then plus 5 into L of cos t, again using the result L of cos at, that is s by s square plus a square. Here what is a? Cos at, here a is 1. So 5 into s by s square plus 1 square, that is 1. That's all. So the result is 3 divided by s minus 5 plus 5s divided by s square plus 1. And one more problem. Find L of t square plus e power minus 5t plus 8 plus sin h 5t. So here each term will be a single question. I can together I can add all the functions for explain in single problem, right? So L of t square, we can again by using a property of linearity, we can take Laplace transform in each and every term. So L of t square plus L of e power minus 5t plus 8 into L of 1. 8 is constant, so we can take 8 into 1, that is 8 into L of 1 plus L of sin h 5t, right? So by using the result, L of t square means t power n. The result of L of t power n is nothing but n factorial by s power n plus 1. So here what is n? Here n is 2, t square, isn't it? T square means n equal to 2. So by the result, 2 factorial divided by s power 2 plus 1, that is 2 factorial by s cube, that is 2 by s cube. And second one is nothing but a Laplace transform of e power minus at form. So that the result is 1 divided by s plus 5. And the third term is plus 8 into L of 1, that is L of k. L of k means k by s, k is constant. So here 1 by s plus L of sin h 5t. Sin h 5t, that is sin h at format. That is a divided by s square minus a square. So here a is nothing but 5. So that 5 divided by s square minus 25, right? So these two problems will be explained solved by using the results. This is one more problem. Find L of cos square t. we know that if the function is a linear, if the function is in linear form, uh, for example, previous problems like that, but this is not in linear. So that first we can rewrite the function into linear form. So this is of the form cos square theta. This is of the form cos square theta. So we can using the equivalent formula. Cos square theta is nothing but 1 plus cos 2 theta divided by 2. 1 plus cos 2 theta divided by 2. So here theta is nothing but 2t, right? So the 2 into 2t. So 1 plus cos 2 into theta is 2t. So that it becomes 4 times t. So 1 plus cos 4t divided by 2. And then here also we are having two terms. So similar previous problem, we are separating or applying Laplace transforms to each and every term. So we can take the 1 by 2 as common. So 1 by 2 into L of 1 plus L of cos 4t, right? And then 1 by 2 into L of 1 is 1 by s. L of cos 8t means s by s square plus a square. So this is s by s square plus 16. 4 square, that is 16. That's all. This is the simplified solution of this problem. Similarly, next problem is of the form sin A sin B. If we have single function, we can use the results directly, or otherwise, if the function is in not in the single form, or it may be in product form or square or cube, we can use equivalent trigonometric formulas to rearrange the complicated functions into linear form and then applying the results. So likewise here we see that this is of the form sin A sin B, right? Sin A sin B. So the formula for sin A sin B is nothing but 1 by 2 into cos of A minus B minus cos of A plus B, right? So here A is 2t, B is 3t. So cos of A minus B means 2t minus 3t. That is cos of minus t. But we know that cos of minus theta is equal to plus cos theta because cos is an even function, right? So the first term becomes cos t. And then minus cos of A plus B. A is 2t, B is 3t. When we add together, it becomes 5t, right? That's all. And then we can applying Laplace transform results in each functions. We got the result as 12s by s square plus 1 into s square plus 25. So first we can using the result write the solution and then simplifying, we get the final solution. So this is one more problem in which we are seeing that the function will be separated into two intervals. First one is on the interval 0 to pi, the function will be cos t, and on the interval greater than pi, it will be 0. So that how can we find the solution means we can write the formula of Laplace transform, and then but our limit is we know that integral 0 to infinity only, but the given function having the period of interval as 0 to pi and pi to infinity. So that likewise we can separate the integral into two parts. One is integral 0 to pi e power minus st into f of t dt plus integral pi to infinity. There will be a continuous function, right? So integral 0 to pi and pi to infinity e power minus st f of t dt. Now we are going to replace the corresponding functions in the corresponding intervals. We see that on the interval 0 to pi, the function is cos t. So here we can replace in the first integral term, we can replace the function by cos t. So integral 0 to pi e power minus st cos t dt plus what about second integral? Second integral becomes 0 because t is greater than pi, the function will be 0. So when we replace here f of t by 0, it will be cancelled. That's all. And then the result, the problem will be reduced as integral 0 to pi e power minus st cos t dt. Here also we are seeing that there are two functions in terms of t. So we are not able to directly integrating uh, this integral, but we are having some result. What is the result integral formula? We are having one, that is integral a to b e power x cos bx dx. That is the formula. The formula is nothing but e power ax by a square plus b square into a cos bx plus b sin bx. That is the formula. So here t equal to x. When we comparing this result with the formula, t equal to x, a equal to minus s, and b equal to 1. So using the formula, we see that e power minus st by s square plus a square plus b square. A is s square, b is 1. So 1 square 1. So into formula is a cos bx plus b sin bx. So minus s cos t plus 1 into sin t. So this is the formula, equivalent for formula for reducing this, for integrating this problem, and then applying the limit 0 to pi for a t. It becomes upper limit is pi, so e to the power minus pi s. We can replace the limits for t only. So e power minus pi s by s square plus 1 into minus s cos pi plus sin pi. Then minus of lower limit, e power 0, that is 1 by s square plus 1 into minus s cos 0 plus sin 0, right? So after simplifying, we get the result as s by s square plus 1 into 1 plus e power minus pi s. So in this problem, we understand that if the function will be divided into two period of intervals, then we are separating the integral function also into two parts. And then a few properties of Laplace transform. One is first one is a linearity property. That is nothing but the two functions f of t and g of t are continuous functions, and k is a constant. Then the property is L of f of t plus or minus g of t is equal to L of f of t plus or minus L of g of t. So already we are discussed some problems by using linearity property. Linearity property means either addition or subtraction. We can applying the Laplace transform to the functions individually. That's all. And L of k into f of t means this is also another property that means where k is a constant. K into L of f of t. When we applying the Laplace transform to the constants and also functions, the constant will be a constant only. That shows this result. And next one is shifting property, very important one. Shifting property is nothing but if the function, if the function L of f of t, sorry, if the transformation L of f of t is equal to f of s, then L of e power minus at into f of t is nothing but f of s plus a. See that very carefully. L of f of t means the transformation is f of s only. But if the function is in the form L of e power minus at into f of t, then the transformation is like f of s plus a. So this is nothing but shifting property. For removing this exponential part from the given function, we can write as f of s plus a. And this is change of scale property, frequently asked question. Change of scale property is also nothing but the statement is if L of f of t is equal to f of s. This is standard one. Then in the function there will be some changes, then the transformation also there will be some changes. So L of f of a into t, f of a into t means the result becomes 1 by a into f of s by a, right? So this is the very important property in Laplace transform. So now, based on shifting property and a change of scale property, we are going to discuss some problems. So first one is find the Laplace transform of t divided by e power t, right? So t divided by e power t, I can applying shifting property for solving this problem. How we can apply means bring the denominator to the numerator, it becomes L of e power minus t into t. So by using shifting property, I can remove e power minus t inside the bracket. For that L of t, we can just replace s by s plus a. That is the shifting property. So L of t, where s tends to s plus 1, because here a is minus 1. So here we can write the number in the positive number only. So L of t, s tends to s plus 1. So we know that the result of L of t is nothing but 1 by s square. And in this result, just replace s by s plus 1. So that the Laplace transform of the corresponding function is 1 by s plus 1 whole square, right? And one more example. Here we see that it is also under the case of shifting property. So first we have to eliminate the exponential part from the function f of t. For that we can replace after the transformation in the solution s by s minus a. So here we see that e power 2t. So that L of cos pi t, in this result we can replace s by s minus 2 because a is here 2 plus 2. So in the replacement we are making negative number. And we know that the result of L of cos phi t is nothing but s by s square plus a square. That is s by s square plus 25. And then we can replace s by s minus 2 in the final result. Therefore, s minus 2 by s minus 2 the whole square plus 25 is the final result. So likewise, you have to practice many problems. And this is nothing but if the function, this is another result, just we have to take the statement only. Here we see that the function will be multiplied with the t, in general t power n. So for removing this t or t square or t power n, we can use the formula minus 1 whole power n into d power n by ds power n of L of f of t or f of s, which means if the function is multiplication with the t, for removing t we can take differentiation, right? So for example, let us see this problem. Find L of t into cos 3t. So here we see that the function f of t is cos 3t, which is multiplied with the variable t, right? So first step is we are going to remove this t by using the result. This is t power 1. So in this general formula, we can replace n by 1, right? So minus 1 power 1 into d by ds of f of s. So that here minus 1 d by ds into L of f of t. F of s is nothing but L of f of t. So minus 1 d by ds L of cos 3t. So for removing this t, we have to introduce the differentiation with negative or positive power. If the power of t is odd number, it will be minus. If it is even number, it will be plus. That's all. So here one is odd number, so minus d by ds L of cos 3t. So minus d by ds. We know that the result of L of cos 3t is nothing but s by s square plus a square. That is s by s square plus 9. Here a is 3. After that, take the differentiation of this term with respect to s. So we can apply u by v rule, division rule, right? Let us consider s as u and s square plus 9 as v, using the u by v rule, division rule, that is vu dash minus uv dash by v square. After that, we can we get the result as s square minus 9 by s square plus 9 whole square. So first example, in the first example, we see that the power of t is 1. The second example, we see that the power of t is 2. That is L of t square sine at. So if the power is 2, then the result becomes minus 1 whole square d square by ds square of L of sine at, right? So now here we see that second degree differentiation. So we can differentiating the function transformation 2 times, then only we got the result. And this is a property by using integral or the function will be divided by t. In the function we are seeing that divided by t. We can use the formula integral s to infinity L of f of t ds. So in this particular example, we see that the function is f of t is 1 minus e power t, which will be divided by t. So first step is we have to eliminate this 1 by t. For that, for the elimination purpose, we can take integral s to infinity L of f of t. Therefore, L of 1 minus e power t ds. Now, first we can applying the Laplace transform for this function. Therefore, L of 1 is 1 by s minus L of e power t is 1 by s minus 1, because a is 1 here. So 1 by s minus 1 ds. And then take integration of this one. We know that the integral of 1 by s is log s. And similarly 1 by s minus 1 is log of s minus 1, and then take limit. Before applying limit, we can use the logarithmic result. One of the logarithmic result, log a minus log b, that is log of a divided by b. So it becomes log of s by s minus 1, and then applying the limit s to infinity for s. Before going to applying upper limit, we can rewrite the function as or we can divide by s, both in the numerator as well as denominator, uh, because if we directly substitute the upper limit, the result is infinity. There is no finite result occurred, so that I can divide s in the numerator as well as denominator. So it becomes 1 divided by, in the numerator is 1 divided by, in the denominator is also 1 minus 1 by s. After then we can applying the upper limit infinity for s, we get 1. See here we see that log of 1 divided by 1 minus 1 by infinity. 1 by infinity is 0, so that 1 by 1, so log 1. After then the lower limit becomes log of 1 by 1 minus 1 by s, that is nothing but after taking LCM we get log of s by s minus 1. So finally the log 1, the value of log 1 is 0, and the result is minus log of s by s minus 1. We bring the minus 1 to the numerator, because a log b, another result of logarithmic, a log b is log b power a, so that the final solution will be the reciprocal of the fraction. So log of s minus 1 by s minus s. So here we see that if the function will be divided by t, so we are before applying Laplace transform, to eliminate the term t in the denominator, we can take integration and applying the limit s to infinity. So if the function is multiply with the t, then we can take derivative, differentiation, or divided by t, we can take integration. So I can explain one more problem and then move on to the next topic. So here also we see that very important result this one is, so L of e power minus at minus e power minus bt divided by t. Here I am going to first eliminate the divided by t term by introducing integration s to infinity L of e power minus at minus e power minus bt ds, right? And then applying the Laplace transform in each term. First term is L of e power minus at. The result is 1 by s plus a. And second one is e power minus bt. The result is 1 by s plus b. And then we can take integration of this function, this transformation, the same process. 1 by s plus a is nothing but log of s plus a. Integration of 1 by s plus a is log of s plus a, and 1 by s plus b is log of s plus b. And then applying the limit infinity, using the logarithmic property, log of s plus a by log s plus b, and after applying the limit infinity, we get the result as log of s plus b by s plus a. Same thing here also, before going to applying infinity, you can divide both and the denominator by s. Then only we got the finite solution, or otherwise it will be infinity. So let us practice more number of problems. Third problem is also same methodology. Now the next important topic, definitely one question is from this topic, Laplace transforms of a periodic function. So here what is the definition means, a function f of t is periodic if there exists a positive constant t such that f of t plus t is equal to f of t. F of small t plus capital T is equal to the function, the given function f of t for all t. So here the smallest of such capital T is called the period. The difference between small t and capital T is nothing but a period of the function. For example, sine of t plus 2 pi is nothing but sine t. Here capital T is 2 pi, so that we conclude that the period of the sine function is 2 pi. The period of the sine function is 2 pi. I will explain this sine function is a periodic function with the period 2 pi in pictorial representation in the next slide. Before that, this is the formula for periodic function by applying Laplace transform. So L of f of t is equal to, the formula for periodic function is 1 divided by 1 minus e power minus st integral 0 to t. Only the upper limit is up to t only, finite limit, into e power minus st f of t dt. So this is the basic formula for finding Laplace transform using periodic functions, right? So the example is, listen here, this pictorial representation shows that the function sin x has period 2 pi. From the diagram, we see that the curve starts from 0. Sin 0 is 0. Sin pi is 0. Sin 2 pi is 0. So the curve starts in the origin and slightly increase and decrease in the fourth quadrant, and up to 2 pi. Up to 2 pi, the curve 0 to 2 pi will occur the same image on the next 2 pi to 4 pi. So the period of sine function is the same image will appear only in the period of 2 pi for sine function, right? That's why we say that sine function has a periodic, it is a periodic function with a period 2 pi interval, right? So now let us see the example by solving Laplace transform by using periodic function. Find the Laplace transform of the rectangular wave function given by f of t is equal to 1 minus 1. F of t is equal to 1 on the interval 0 to b and minus 1 on the interval b to 2b, with f of t plus 2b is equal to f of t, right? So this is the problem given. This wave is nothing but rectangular wave function. Here the function will be separated into two functions with the specific period of interval. And here 2b is the maximum point, closed interval. So the in this formula we can take capital T is equal to 2b, so that the formula becomes L of f of t is equal to 1 divided by 1 minus e power minus 2s e power minus s into t. That is the formula. Here capital T is nothing but 2b, so that 1 minus 1 divided by 1 minus e power minus s into 2b, therefore minus 2bs. Integral 0 to 2b e power minus st into f of t dt. So in this formula, we can replace a t by the period 2b, and then our function is splitted into two functions. On the interval, on the first interval 0 to b, the function is 1, and in the second interval b to 2b, the function is minus 1, so that we can separate the integration into two parts. So first one is integral 0 to b e power minus st f of t dt, plus integral b to 2b e power minus st f of t dt. There will be a continuity on the interval, midpoint of the interval is b, and then we can replace uh, corresponding function by in the first function, or in the first interval 0 to b, f of t is 1, so that integral 0 to b e power minus st into 1 dt, and then in the second interval the function is minus 1, so that I can put here minus integral b to 2b e power minus st into 1 dt. After that we can integrating actual original normally integrated e power, first one is integral 0 to b e power minus st dt. The integration of e power minus st is e power minus st divided by minus s, the coefficient of t, and then applying the limit 0 to b. Similarly, the next part, same function. So the result is same only, e power minus st by minus s, b to 2b, and then after applying the limits carefully, we get the line as 1 divided by s into 1 minus, see the third line, 1 by s into 1 minus e power minus 2b into s, into here we see that 1 from the second line 1, and then we are having 2 times of minus e power minus bs, so that 1 minus 2 times e power minus bs plus e power minus 2bs. After that, for simplifying purpose, I can rewrite the last term as e power minus 2bs as e power minus bs the whole square. That is a minus b whole square. My aim is to convert the numerator into a minus b whole square format. So here a equal to 1, b equal to e power minus bs, so that a square 1 minus 2 into a is 1 into e power minus bs plus e power minus bs the whole square. So the numerator becomes 1 minus e power minus bs the whole square, and in the denominator also I can rewrite the term e power minus 2bs as e power minus bs the whole square, and first one is 1 square. So the denominator is of the form a square minus b square. The formula is a minus b into a plus b. Therefore 1 by s into 1 minus e power minus bs into 1 plus e power minus bs. So here we are saying that one of the term in the numerator getting cancelled, that is 1 minus e power minus bs the whole square is in the numerator. In the denominator 1 minus e power minus bs whole power 1. So we can eliminating one of the term. It becomes 1 minus e power minus bs divided by s into 1 plus e power minus bs. So using the formula, write 1 by s as it is. Using the formula 1 minus e power minus theta by 1 plus e power minus theta, the result is 1 by s into tan h bs by 2. If here the theta is minus bs, in the result we can divide by 2. We can write theta divided by 2 only. That is the formula. So that 1 by s tan h bs divided by 2. So this is the way how to solve functions by using periodic formula. So triangular wave function, next problem. This is also very important one. Here also see that the period of the function is 2a. On the interval 0 to a, the function is t. On the interval a to 2a, the function is 2a minus t. We can using the same formula separate the integration into two parts and applying the functions carefully. After taking integration, finally we got the result as 1 by s square tan h as by 2. The same procedure, the simplification procedure is like the previous problem for all the functions. This is another one important problem. Here also we see that this is nothing but a half sine wave rectifier function. The name of the function is half sine wave rectifier function. So here the period of the function is 2 pi by omega, and we see that on the interval pi by omega to 2 pi by omega it becomes 0. So that the formula becomes integral 0 to 2 pi by omega e power minus st into s sin omega t dt. In front 1 divided by 1 minus e power minus s into, in the place of t we have to replace 2 pi by omega. And already I told that the formula integral e power ax sin bx dx, the same formula, using the same formula we have to solve this problem. And next topic is initial value theorem and final value theorem in the Laplace transform. Initial value theorem means we have to check both left hand sides and also right hand sides. We have to verify the result. For initial value theorem, limit t tends to 0 f of t is equal to limit s tends to infinity s into f of s. If both the left hand sides and right hand sides are equal, then we conclude that the function satisfies the initial value theorem. And final value theorem is nothing but limit extension will be interchanged. In the left side, t tends to infinity because final value theorem. So in the left side, limit t tends to infinity f of t, and the right side we see that limit s tends to 0 s into f of s. So this is the main difference between the initial value and final value theorem statements. So based on this topic also we are expected big questions. So I will explain with one example. Verify the initial value theorem. We have to verify initial value theorem for the function 2 plus 3 cos t, right? So left hand side is nothing but limit t tends to 0 f of t. Right hand side is nothing but limit s tends to infinity s into f of s. Okay. So first I am going to find f of s, right? That is L of f of t. By linearity property, 2 into L of 1 plus 3 into L of cos t. We got the result as 2 by s plus 3 into s by s square plus 1. This is f of s. Now left hand side becomes limit t tends to 0 f of t is equal to limit t tends to 0, f of t is 2 plus 3 cos t. So we can applying the limit or by putting t equal to 0 in this function. Wherever we are having t, we should replace by 0. So 2 plus 3 cos 0. Here only we are having t. So 2 plus 3 cos 0. What is the value of cos 0? Cos 0 is 1. So that 2 plus 3, 5. So the left hand side value is 5. Now we are going to check the right hand side value. Limit s tends to infinity, s into f of s. That is the result of right hand side. So s into f of s is this one. Substitute here and then multiply this s inside the term. So 2 by s into s getting cancelled. Here plus 3s into s. So 3s square by s square plus 1, right? And then applying the limit s tends to infinity. Before going to applying, we can divide s square in both numerator as well as denominator. So in the numerator, it becomes s square by s square. In the denominator, we can take s square as common. It becomes 1 plus 1 by s square. We can eliminating s square in both numerator and denominator. After then only we are going to replace s by infinity. Then only we got the finite result, or otherwise it will be infinite solution. So for avoiding the infinite solution, we are doing like this. So here, in this place, 1 by s square, when we applying or replacing s to infinity, it becomes 0. So 1 by 1 plus 0. So 2 plus 3, 5. So that both LHS and RHS are verified. Therefore, the initial value theorem is verified for this particular function. This is a very important problem. Please, you have to practice this problem. 1 plus e power minus t into sine t plus cos t is very, very important. Repeated question. And final value theorem, the same process. First, we have to find a capital F of s. Just one thing is, for left hand side, we can take limit t tends to infinity. And in the right hand side, we can take s tends to 0. Check whether both LHS and RHS having the same value or not. If it is same, then final value theorem is verified. And now I am coming to the inverse Laplace transform. This is nothing but the transformation function will again converted into differential equation format. That is only inverse Laplace transform. So L of the definition is, if L of f of t is equal to f of s, that is nothing but Laplace transform. But inverse is L inverse of f of s is equal to f of t. Just to bring L to the right side. So L inverse of f of s is equal to f of t is called inverse Laplace transform. Like Laplace transform, we are having same results in inverse Laplace transform also. So let us see this result. L inverse of 1 by s. L inverse of 1 by s is 1. That is, if the function f of t is 1, then the transformation 1 by s. If the transformation is 1 by s, then the result is 1. Same thing. So then next one is 1 by s minus a means e power at. 1 by s plus a means e power minus at. 1 by s square means t. In general, 1 by s power n plus 1 is equal to t power n by n factorial. Bring this n factorial to the right hand side. So 1 by s power n plus 1 is equal to t power n by n factorial. So these are all the basic results which will be commonly arrived in the solution of the inverse Laplace transforms. So let us see one example. Find L inverse of we are having here 4 terms. So individually we can apply inverse Laplace transform, right? So L inverse of 1 by s square first term plus L inverse of 1 by s plus 4 second term plus L inverse of 1 by s square plus 4 third term plus L inverse of s by s square minus sign fourth term. So individually we can take inverse Laplace transform, right? So in the first term, the transformation is 1 by s square. By the result, it will be t. And in the second term, it is of the form 1 by s plus a. 1 by s plus a means e power minus at. So here a is 4, therefore e power minus 4t. In the third term, it is 1 divided by s square plus 4. If s divided by s square plus 4, then we can know about the result cos 80. Or otherwise a divided by s square plus a square, it becomes a sin 80. But in the numerator, the constant is 1. So we can see that the result we are going to applying the result of cos 80 only. So the formula is a divided by s square plus a square. So here in the place of a square, we see that 4. Then what is a? 2. But in the numerator, there is no a, there is no 2, that is missing. So for making the numerator as a 2, we can multiply and divide by 2. So that 1 by 2 into L inverse of 2 divided by s square plus 4. And the last term is nothing but hyperbolic function cos h at. So here a is 3. So cos h 3t. Only thing, in the third term, we are multiply and divide by 2 for finding the inverse Laplace transform. So that 1 by 2 into, this is nothing but sin 80 form, right? So result of sin 80, so sin 2t. So therefore, for this problem, each term has the inverse Laplace transform as a t plus e power minus 4t plus 1 by 2 sin 2t plus cos h 3t, right? Likewise, we are practice many problems. And then main part, inverse Laplace transform, repeated question is asked from by using partial fraction method or convolution method. So now we are discuss about partial fraction method. There are some 3 different cases of techniques are we are having in the partial fraction method. One is case one is factors are linear and distinct. For example, if the problem is in the form of p of s by s plus a into s plus b, s plus a power 1, s plus b power 1, that is called as linear factors. So after taking partial fraction, it will be written as f of s is equal to a divided by s plus a plus b divided by s plus a, because in the denominator we are having 2 factors, so definitely we are going to find 2 constants. So it will be partial fraction as a divided by s plus a plus b divided by s plus b. A is one constant, b is another constant. This is one case. And case number 2, if the factors are linear and repeated, so it will be checked by using the denominator only. So in this case too, we see that s plus a power 1, one factor. Another factor is s plus b power n. So here it will be partial fraction as a divided by s plus a for the first factor, and for the second factor it will be of some power n. So it will be find out by b divided by s plus b, and then c divided by s plus b the whole square plus d divided by s plus b the whole cube plus etc. We can increase the power of the factor one by one in the next ratios. So this is a repeated and linear factor form. And case 3 is factors are quadratic and distinct. If the denominator in the form of a second degree or quadratic, we see that each factor having 2 roots, 2 constants, so that it will be partial fraction as as plus b divided by the factor plus cs plus d divided by the another factor. So these are all the different types of partial fraction expansion techniques. Like one example, inverse Laplace transform 1 by s plus 1 into s plus 2. So this is case 1, because in the denominator we see that there are 2 factors, both are having power 1. So there are 2 constants. It will be partial fraction as a divided by s plus 1 plus b divided by s plus 2, right? After that, we can take LCM in the form of s plus 1 into s plus 2, because the left hand side we see that the denominator is s plus 1 into s plus 2, the same will be appear in the right hand side also. So for taking LCM as s plus 1 into s plus 2, we can cross multiply a into s plus 2 plus b into s plus 1 divided by s plus 1 into s plus 2, right? After that, we see that the denominator will be cancelled from both sides. So the result becomes 1 in the left hand side, 1. 1 is equal to, in the right hand side, a into s plus 2 plus b into s plus 1, right? After then, this is the main equation. After then, we can putting some suitable values for s for finding the constants a and b, right? when we put s is equal to -2 or -1, I can put s is equal to -2 here, a getting cancelled, -2 plus 2, 0 into a. So, but in b, -2 plus 1, -1. So, minus b equal to 1, therefore b equal to -1. If I can put s is equal to -1, b getting cancelled. So, therefore, we got the value of a, 2 minus 1, 1 into a, therefore a equal to 1. So, that this transformation, this fraction will be separated as 1 by s plus 1, because the value of a is 1 by s plus 1, and the value of b is -1. So -1 by s plus 2. After then, we can take inverse Laplace transform for this term. So it becomes L inverse of 1 by s plus 1 minus L inverse of 1 by s plus 2. That's all. Applying L inverse in both the terms. This is of the form L inverse of 1 by s plus a. Therefore, e power minus at. Here a equal to 1. So e power minus t. And similarly, 1 by s plus 2 means e power minus 2t. Right? So first we have to use partial fraction technique for separating the given fraction, and then after finding the constants, applying the constants in the relevant places, and then take L inverse on both sides, which gives the required solution. So second problem is under case 2, because here the denominator has two factors. One is s power 1 linear factor, second one is s plus 3 whole power 3. So totally we are having uh, power 4 in the denominator. So definitely we are having 4 constants. So that a, b, c, d are the 4 constants. It will be separated as a divided by s for the first factor, plus second factor b divided by s plus 3 only, and then c divided by s plus 3 the whole square, raise 1 of the power, and then plus d divided by s plus 3 the whole cube. So stop up to this, because our power is up to 3 only. So s plus 3, s plus 3 the whole square, s plus 3 the whole cube. So this is the way we have to partial fraction, applying partial fraction in this fraction. And then the same process, take LCM, and by putting suitable values for s, or otherwise we can equating the coefficients of s cube, s square, or s, or maybe constant also, where we are having some equations. After solving all the equations, we get the values for all the constants. After that, applying the constants in the relevant places, taking L inverse in each and every term, and applying the results, find the required solution. So this example shows that case number 3, partial fraction technique, case number 3. First factor is linear factor, so therefore a by s plus 2. Second factor is second degree quadratic form. So in this second factor having two constants, so it will be taken as bs plus c. And then the same process now, you can applying LCM and find the constants, and finally take the L inverse. And let us see the result. We know that L of t into f of t is equal to minus f dash of s, or L inverse of f dash of s is equal to minus t into f of t. So this result used mainly for solving the problems of logarithmic functions, or inverse trigonometric series, inverse trigonometric functions. So then the end of the line, the end line is nothing but this result is used to solve the problem of logarithmic functions and inverse trigonometric functions. So let us see the problem of logarithmic function. L inverse of to find the inverse Laplace transform for log. So this is nothing but inside the bracket we are having capital F of s, right? So first we can, since this is in the form of log, it will be written as log a minus log b, log of a by b. So log a minus log b. First step, we have to differentiating the transformation, that is f dash of s. Log of s square plus a square means 1 by s square plus a square, into applying chain rule into the variable s, variable is s, so 2s. So 2s by s square plus a square, again minus log of 1 divided by s square minus b square into 2s. So that the differentiation of f of s is nothing but 2s by s square plus a square minus 2s by s square minus b square. Now we can take L inverse for this derivative. So we can applying L inverse in the right hand side also. So 2 into 2 is constant. So 2 into L inverse of S by S square plus A square minus 2 into L inverse of S by S square minus A square. And then by the result, we know that the first one is cos AT, second one is cos HBT, because in the denominator there will be negative number. So by the result, it becomes cos HBT. And then left hand side is nothing but minus t into f of t. From this result, the last line, minus t into f of t is nothing but L inverse of f dash of s. Right? So that f of t, here we are going to find the corresponding function, right? For logarithmic function, so that we can apply this result. So that f of t is equal to minus t. Just to bring down minus t to the right hand side, the result becomes f of t equal to 2 by t into cos hbt minus cos at, because I can multiply the minus inside the bracket. So for logarithmic series and inverse trigonometric function, we have to use this result. This is another example for a inverse trigonometric function, same methodology. F of s is tan inverse of a by s. First step is we have to find the derivative of the trigonometric function f dash of s, that is tan inverse of a by s. Tan inverse of x is 1 by 1 plus x square. So it becomes 1 by, here x is nothing but a by s. So 1 divided by 1 plus a square by s square. Again into applying chain rule, a by s, when we differentiating a by s, it becomes minus a by s square. And then take LCM in the denominator, it becomes 1 by s square plus a square by s square. Bring the s square to the numerator, here it will be cancelled, s square cancelled. So the derivation differentiation of f of s is minus a by s square plus a square. And the same applying L inverse, this is sin at. By the property, it becomes f of t equal to sin at by t. Therefore, inverse Laplace transform of the inverse trigonometric function is sin at by t. That's all. And convolution method, this is also one of the main important topic for finding inverse Laplace transform. The definition of convolution is the product of two functions f star g is nothing but f of t star g of t. Here star represents convolution operator. So the formula of convolution method is f star g of t is equal to integral 0 to t f of u into g of t minus u du, which means we have to replace in the first function t by u, and in the second function t by t minus u, after then taking integration with respect to u. So one example, using convolution theorem, we have to find L inverse of 1 by s plus 1 into s plus 2. First step, we have to separate the fraction into two functions. Therefore, 1 by s plus 1 into 1 by s plus 2. Give the name as f of s and g of s. This is first step. Second step, L inverse of f of s into g of s is equal to applying L inverse in each transformation. So L inverse of f of s, in which put the star operator, convolution operator star. When we applying inverse Laplace transform to the transformation individually, and that case we can write the star operation, right? So then L inverse of 1 by s plus 1, f of s is nothing but 1 by s plus 1. So L inverse of 1 by s plus 1 star L inverse of g of s is 1 by s plus 2. Now find out the inverse Laplace transform of 1 by s plus 1 is e power minus t, and 1 by s plus 2 is e power minus 2t. So now this is of the form f of t star g of t. So first function is e power minus t. Here I am going to replace t by u. And in the second term, second function is e power minus 2t. Here I am going to replace t by t minus u and take limit, integral 0 to t du. So here after simplifying, e power minus u into e power minus 2t into e power plus 2u, right? So here we see that the integration is only with respect to u. So that e power minus 2t is considered as constant. Take outside from the integration. And then e power minus u into e power 2u. becomes e power minus u plus 2u, that is plus u. So the integral function becomes e power minus 2t integral 0 to t e power u du. After applying the limit for after taking integration, then applying the limit, the result becomes e power minus t minus e power minus 2t. So for convolution, we have to separate the function fraction into two functions, and then applying star operation, and then take inverse Laplace transform, and then replace in the first function t by u and in the second function t by t minus u. After simplifying, get the final result. So this is also very important problem. You practice. You can practice L inverse of s square by s square plus a square into s square by s square plus b square. So in this problem, we see that in the numerator also we are having the parameter s square, so that it will be uh, splitted as s by s square plus a square into s by s square plus b square, and then the same process. And finally, the solution of second order differential equation will be obtained by using Laplace transform. For that, these two results will be uh, well known. L of f dash of t, first derivative L of f dash of t will be replaced by s into L of f of t minus f of 0. And for the second derivative L of f double dash of t, it will be replaced by s square into L of f of t minus s into f of 0 minus f dash of 0. So these two results are very, very important for converting the differential equation into fraction form. An example, so here the ordinary differential equation given as y double dash plus 5y dash plus 6y equal to 2 with the initial conditions y dash of 0 equal to 0, y of 0 equal to 0. We can apply Laplace transform for solving this problem, right? So first step is we have to take Laplace transform on each and every term of both sides, so that L of y double dash, L means Laplace transform, L of y double dash plus 5 into L of y dash plus 6 into L of y, because constant, when we take Laplace transform for constant, it will be again a constant only, so that I can directly take a constant outside the transformation. So L of y double dash plus 5 into L of y dash plus 6 into L of y is equal to 2 into L of 1, right? So now using the previous result, first term is second derivative L of y double dash. The formula is this one. L of y double dash will be written as s square into L of y minus s into y of 0 minus y dash of 0. This three terms is written instead of L of y double dash. Then plus 5 into L of y dash using the another result s into L of y minus y of 0. So 5 into 5 is common. 5 into s into L of y minus y of 0 plus 6 into L of y, right as it is, equal to 2 into L of 1. Now, in the first step, applying L in each and every term. Second step, applying the result. Third step, applying the value of the initial conditions. Here we see that y of 0 equal to 0, y dash of 0 equal to 0, which is given in the problem. So in this expansion, we have to replace y dash of 0 equal to 0 and also y of 0 equal to 0, right? After that, simplifying, for that we can take L of y as common, because I need the solution for y. I need the solution y only for this differential equation, so that I can take L of y as common. Here, first term and fourth term and last term having L of y. So from these three terms, I can take L of y as common. So in the first term, the coefficient is s square, and in the fourth term, 5 into s, and in the last term, plus 6. So L of y, take L of y as common, then the remaining terms are s square plus 5s plus 6. And then second term getting cancelled, third term getting cancelled, and this term also getting cancelled, because the initial conditions are zeros only. And in the right hand side becomes 2 into 1 by s, therefore 2 by s. So therefore, bring the factor, the equation s square plus 5s plus 6 to the right hand side, and keep L of y in the left hand side, so that L of y is equal to 2 divided by s into s square plus 5s plus 6. After that, taking factorization, the roots are s plus 2 and 3. So the factors are s plus 2 into s plus 3 because s square plus 5s plus 6. Constant term is 6. Middle term is the coefficient of middle term is 5. We can choose any two real numbers. 2 into 3 is 6. 2 plus 3 is 5. So that the factors are s plus 2 into s plus 3. So the denominator becomes s into s plus 2 into s plus 3. Then this and all only the new steps we are introduced. After then the same process. Y equal to L of I இருக்கு இல்லையா அதுல இருந்து L மட்டும் ரைட் சைடு கொண்டு போயிருங்க. Y equal to L inverse of 2 divided by s into s plus 2 into s plus 3. Just we can take inverse Laplace transform by using either convolution method or partial fraction method. Which one is suitable for the problem? You can choose. That is your choice. So this is now this is suitable for partial fraction technique. So I am taking partial fraction. I am following partial fraction technique for finding the inverse Laplace transform. That's all. So this is the methodology for solving ordinary differential equations by using Laplace transform. So first step is we have to take a Laplace transform on both sides and then applying the result and then applying the initial values for the given initial conditions, and then write the problem into y equal to L inverse form and then find the inverse for the fraction. You have to practice many more problems, right? Then only it will be easy to write in the exam. Now various applications of Laplace transforms. The real life applications are in semiconductor mobility. Laplace transform is applied in many ways, and in call completion in wireless networks, vehicle vibrations on compressed rails, behavior of magnetic and electric fields above the atmosphere. These and all the real life applications of Laplace transforms. And in more many wide applications are there in several engineering disciplines. They are one is system modeling. Laplace transform is used to simplify the calculations in system modeling, in where the differential equations are in very large number, very large power. And the analysis of electrical circuits also Laplace transform is applied. It is used for analysis of linear time invariant systems. In electronic circuits also, Laplace transform used to solve the problem quickly, to solve the differential equation problem very fastly. And in the digital signal processing also, there is no way to solve any kind of problem without the help of Laplace transform. And in department wise applications of Laplace transform, in EC department, in the paper of signals and system, in which the specific topic energy signals, time signals, here all Laplace transform applied. And in control systems also there is many usage of Laplace transform. In EEE department also, control systems, circuit analysis, current flows, in all the topics Laplace transform will be applied. In E&I also, control systems, circuit theory. In mechanical, heat and mass transfer, especially to solve partial differential equations, Laplace equations, heat equations. This kind of equations are solved by using Laplace transform techniques. And in general, all the fancy works of image matching, face recognizing, 3D map creation, video processing, sound processing also done by using Laplace transform. And in electric analysis, communication engineering, control engineering, linear system analysis, statistics, optics, quantum physics, nuclear physics, these and all are general applications of Laplace transforms. Thank you. Any doubts?
Thank you, ma'am. Thanks for the wonderful session. It was very knowledgeable and insight information. Now we have come to question and answer session.
Ma'am, we have some queries from our participant. Due to time limitation, some questions will be answered. And the first
Okay.
question is,
Yes.
what is continuous function? Can you explain it with an example, ma'am?
Continuous function means the function will be differentiable. The differentiation of the function exists in both left hand sides and also right hand sides. The value exists, same value exists in both left hand side as well as right hand side.
Thank you, ma'am. Then next question. Other than Laplace transform, do we use any other transforms in engineering, ma'am?
Fourier transforms. Other than Laplace transform, Fourier transform will be used for solving the difference equations, which will be in the third semester.
Thank you, ma'am. And the next question is, ma'am, where do we apply Laplace transform in real life, ma'am?
In real life, many areas like system modeling, nuclear physics, and then for finding the signals and system. These are all the various field of applications of Laplace transform.
Thank you, ma'am. And why do we use partial fraction method, ma'am?
Because the simplification purpose of for finding the inverse Laplace transform is much better than other methods. That's why we are always suggest partial fraction technique, because in school level also we are very well known about how to solve partial fraction problems.
Thank you, ma'am. And the next
Thank you.
is, what are the importance of Laplace transform, ma'am?
The importance of Laplace transform is to solve the problems in an easy manner by using different techniques.
Thank you very much, ma'am.
Thank you.
Thank you, ma'am, for answering all your queries.
Thank you.
Now, I call upon Ms. Shamla, Assistant Professor, the Department of Mathematics, Science and Humanities from Loyola Institute of Technology, to propose the vote of thanks. Over to you, ma'am.
Thank you, ma'am. Good evening, all. It gives me great pleasure in delivering the vote of thanks for today's webinar on a real life applications of Laplace transform. We are grateful to Mrs. V. Naharani, Assistant Professor, Department of Mathematics, SRM Engineering College, and also it gave a deep insights into the topic and also revealed some interesting facts. And also you gave the applications of Laplace transform, ma'am, in engineering. The students may now know how they have applied the mathematically how they are why they are studying these Laplace transform, because they are applying in each department. Okay, so and then I will extend my thanks to our administrator and our principal, Dr. Sujata Anand ma'am, for their guidance and encouragement for conducting such webinar. I would also like to thank my fellow coordinators, Dr. Ravikumar sir, Roslyn ma'am, Niveda ma'am, for helping to organize this webinar, and the faculties of Science and Humanities. Finally, I convey my gratitude to all the students who attentively attended this webinar and made it interactive by asking relevant questions. And thank you everyone for joining this webinar on Saturday evening. Thank you one and all. Thank you all.
Thank you, ma'am. My hearty thanks to everyone for the great success of this event. Dear participants, the feedback link has been posted in the chat box. Kindly fill it. The feedback link has been posted in the chat box. Kindly fill it. And you will receive your e-certificate within 2 to 3 days. Thank you, everyone. Stay safe, stay home, keep social distance. Thank you. Thanks for all your presence.
Ma'am,
Thank
thank you
you.
so much, ma'am.
And thank you, ma'am.
It
Shall
was
I leave,
very
ma'am?
nice. Okay, ma'am.
Oh,
Thank you, ma'am.
ma'am, I will call you by
Thank
phone,
you.
ma'am.
Okay, ma'am. Okay, ma'am. Sure, ma'am.
Thank you, ma'am. Thank you. Bye, ma'am.
Thank you, ma'am. Thanks a lot, ma'am.
Thank you.
Students, please fill the feedback and then leave the meeting. Students, kindly fill the feedback form and then leave the meeting.